My name is Hendrik Makanata, and I'm just going to start with our lesson today for finance, grade 12 mathematics. And of course, what is important is that we recap the chapter on finance, which we started last week already. And up to so far, we have spoken about the simple interest, the compound interest, the simple depreciation together with the compound depreciation, the nominal and effective annual interest rates. And of course, we carry on to look at a wide range of concepts this morning relating to the content that we have already covered up to so far. And the first one here is just to look at the value of the car when it depreciates on two different levels. The first one being the straight line depreciation, and of course the other one being the reducing balance depreciation. Now, we have to look at the example which follows. Nsako buys a car worth 385,000 rands in 2020. Now, the question that arises from this statement is what will be the value of the car after 6 years? In other words, 2026, which is 6 years from now, what will the value of the car be when we look at both lines of depreciation, the first one being the straight line depreciation followed by the reducing balance depreciation. And of course, you will recall that the formula to calculate the two is different. One is just more like the simple interest formula, except that you will have the negative sign. And of course, the second one being also the negative sign, but with an exception of the compound interest formula, which is different from the original one, which was the simple interest. So if we look at this statement when Sako buys the car, the initial value of the car, of course, is 385,000 rands in the beginning of 2020. And we need to now focus on the straight line depreciation just to be able to tell what will be the value of the car after a period of 6 years. Now, the formula to calculate the depreciation is a straight line formula. And of course, you can tell that we have got A, which is the accrued amount, but in this case, P stands for the principal amount. That would be the amount at the beginning of 2020, and that is the amount of the car, which was bought at 385,000 rands. And you can also tell that the negative sign that we have here simply means that the car, or the value of the car rather, will depreciate, meaning that it will be reduced. And we all know that cars from time to time do get reduced as time goes on. Now, you can already tell that we have been given the interest of 6% on the straight line depreciation. And as you know, once you have got the interest of 6% per annum, this simply means you divide your 6 by 100. That is the interest. And then you multiply by 6, which is 6 years. That is the number of years which it will take for the car, or the value of the car rather, to depreciate. And of course, 1 minus, if you multiply 0.06 by 6, you'll definitely get a 1 there, 1.64. And of course, if you subtract 1.64 from 1 there, you'll get 0.64. And if you multiply that with 385,000, then you will get 246,400. So this simply means that the value of our vehicle, rather the car that was bought by Ntsako, will be 246,400 rands. And this value is what is known as the straight line depreciation. So the car depreciates after a period of 6 years on a straight line depreciation formula, which will take us to 246,400 rands. So that will be the value of the car after a period of 6 years. Now, equally, we also have the reducing balance depreciation. And in this case, we should know by now that the car still depreciates at 6% per annum. And the reason why we are putting this at 6% per annum is for the simple reason we want to be able to do a comparison. In other words, we need to compare the two types of depreciations. And of course, in order to come to a conclusion and to be able to check which one would be the right option to go for, should you have such an option when it comes to buying a car. So we are now going to look at the depreciation, which is now called the reducing balance depreciation. And of course, in this case, the formula will be different, although you will still have your negative sign, but the alternative thing here is that you need to look at the formula which resembles that of a compound interest in this case. You can tell once more that A is equal to P open bracket 1 minus I, and then all to the power of n. So at this point, the n becomes the exponent as opposed to the coefficient of I. And once again, we use the same interest, in this case 6%, and of course 1 minus 0.06, this will give you 0.94, and of course 0.94 to the power of 6 multiplied by 385,000 rands will lead to 265,599 rands and 87 cents. Now, these are the two important values of depreciation. We know that the first straight line depreciation, we got an amount of 240,000. So by the way, that will be the value of the car after a period of 6 years. So if you, in other words, if you want to sell the car after the stipulated period, you will definitely pay or sell it for 240,000 rands, 246,400 if it is on a straight line depreciation, as opposed to the amount of 265,599 rands and 87 cents when it comes to the reducing balance depreciation. It should be very clear at this point that the reducing balance depreciation is not as, is different, in fact, from the straight line, depreciation, in a sense that when you use the reducing balance depreciation, the amount will be far much better than the straight line depreciation. You can tell without doubt that the straight line depreciation value becomes far less than it would be had you chosen the reducing balance depreciation. And of course, you can also look that even when it comes to investments, when you use the simple interest in your investment, the returns on your investment are likely to be less compared to the compound interest formula. So as you can see, even the reducing balance depreciation, which exactly looks like the compound interest formula, except for the negative side, you can tell that the amount will always be bigger than the straight line depreciation. So I would personally opt for the reducing balance depreciation, because although the amount of the value of your car will be reduced, but at least it will not be as low as it would be when we look at the straight line depreciation. So for me, the reducing balance depreciation is a better option that we can go with when we look at the value of the car after a couple of years. And of course, you can even tell that, towards if you were to increase the period, for instance, you will also see that the straight line depreciation will be radically reduced after, say, 10 years as compared to the reducing balance depreciation. So we need to be able to make such a distinction to an extent that even if a question arises where you are asked which option would be better, even without doing calculations, you should be able to tell that the reducing balance depreciation will be a better option than the straight line depreciation if and only if the interest rate remains the same. So this depends on the interest rate. If the interest rate is the same, then the good option will be the second one, which is the reducing balance depreciation. And this is what we mean when we talk about the value of the car. Once again, very important, it's very key that you remember the given data. I always say you need to write down what is given on a piece of paper. In this case, we were given the amount of the car, which is the P, the principal value. That is the amount at the beginning of your transaction. Once again, you are also given the interest rate as well as the number of years. So sometimes the number of years may not be stipulated per se. Like in this case, you know that the transaction took place in 2020, and you need to look at the balance or the balance depreciation at the end of 2026. So if you count from 2020 to 2026, that will be 6 years. And of course, you should be able to identify the data that is given. And once you have got all the given information, by inspection, once again, you should be able to see or to check what is it that is required. In other words, what is missing, especially when we look at the relevant formula. So you can see at this point that the missing value there will be the value of A, which is known as the accrued value. Especially when it comes to, we call it the accrued value because it's the value immediately after, which is impacted upon by the interest rates as well as any other factors, the number of years and so on, And of course, after a period of 6 years, that is what you will have. Now, now that we have, done a little bit of work on the amount or the value of the car after a period of 6 years, it will only make sense that we also look at, the effective annual interest rate. Remember that I have already taught you about the nominal interest rate together with the effective interest rate. And of course, there's a formula that we have used even before in order to calculate the nominal interest rate, when we are given the effective interest rate. So in this case, I want us to look at the annual, interest rate, which in this case will be the effective one. And the next example, we look at the investment, which is made by Joshua. Joshua makes this investment in the bank for a period of 18 months. So in this case, we need to now check how much money will Joshua have at the end of 18 months. And we also need to check what the effective annual interest rate will be if the nominal interest rate is 8%, which is compounded. So in this case, we are also going to identify the given information. You can tell that when you make an investment with the bank, by the time you start at the beginning of your investment, the amount that you invest will be known as the principal amount. And of course, the amount which you will receive at the end of the investment period will be known as the accrued amount, represented by the letter A. Now, the other thing that is given here, we are given the period. In this case, it is given in months. So we have got 18 months. So we know that a year consists of only 12 months. Now, if you add 6 months to 12 months, you get 18 months. This simply means we have got 1.5 year, 1 year and 6 months. That is the period that we have, or you can also say 1.5, which is 1.5 years, or yes, 1.5. So we need to also realize that we are also given the nominal interest rate, which is 8%. But the other key component of this particular activity is the type of interest that we have. Although we have the nominal interest rate, we know that it is not calculated once, it is compounded. So meaning that every month you will have to put interest on interest, unlike the simple interest where you just put interest once in a specific period. So in this one, you calculate interest on the actual amount that consists of the interest. So what I've done here, I've actually divided my spreadsheet into two, where we look at the accumulated amount together with the effective annual interest rate. So in this case, as you can tell, without doubt, we have used the proper formula, that is the compound interest formula. You know that that formula is given by A is equal to P into 1 plus I, then you close your bracket and put N, where N stands for the number of years. And you will see very interestingly that in the beginning there, the accumulated amount, if you do it every year, if you take a year, then you will have, 33,000 671 rands and 7 cents. And that will be the accumulated amount, also known as the accrued amount. And you can also look at that half yearly. If you calculate that half yearly, you are going to divide your 8% by 2 because, it's done half yearly. And if you look at the number of years there, I have already said that 18 months simply means 1.5 a year. That is 1.5. And of course, you multiply that by 2. Why do you multiply that by 2? That's simply because we do it half yearly. And you can tell that the amount becomes increased. But at this point, we should be able to utilize the same process where we calculate the effective annual interest rate. Remember that there's a link between the effective annual interest rate together with the nominal. So if you look at the first one there, after a half a year there, you'll have 8.16. Now, if you do it quarterly, the same goes. You divide your interest by 4. Why do you divide by 4? We divide by 4 because there are 4 quarters in a year. So if you calculate your accumulated amount quarterly, this means it will be done 4 times in a year. The first quarter, the second quarter, third, and fourth. Whereas when it comes to half yearly, there are 2 halves in a year. That is why we have 2 there. Once again, you can do it monthly. Now, if you do it monthly, basically, I've already said to you there are 12 months in a year. So you will, in this case, you'll multiply 1.5 by the actual 12 months in the exponent there, because 1.5, as you know, stands for the 18 months, which is now converted to years. So it will be 1.5 multiplied by 12. And in the same note, you will be able to calculate the effective interest rate, which is now on an annual basis. And in this case, it will be 8.3%. So you can actually tell without doubt that there is a correlation between the accumulated amount as well as the effective interest rate. If you look at the table here, you'll see that as and when the accumulated amount or the accrued amount, as and when it increases, even the effective annual interest rate will increase. And the last one is daily. You can actually calculate the accrued amount on a daily basis. In other words, you can tell what the accrued amount is, on a daily basis. In this case, if you are going to look at daily accumulation, then it means you are now going to look at the number of days in a year. It's normally 365 years. 365 days in a year. And of course, we know it can also be 366, depending on the type of year, the leap year that is. But in most cases, 365 days, and then you multiply that by 1.5. Why 1.5? Because 1.5 simply stands for the 18 months. And you can tell the accumulated amount, if it is calculated daily, will be 33,828 rands and 17 cents. Once more, if you look at the effective annual interest rate, it also increases. And so you can actually tell that when you do it yearly, or the interest rate will be different than when you do it half yearly. So half yearly means twice. So the interest there or the effective annual interest rate will definitely increase. And this has answered our question on the investment, which is made by Joshua at the beginning with the bank, the investment of 30,000 rands, which will increase at the end of the actual period, together with the effective annual interest rate, if the nominal interest rate is 8%. Remember, 8% is compounded, and that is why you see this movements. The 8% is actually compounded, and that is why we use the compound interest formula to look at the accrued amount. So once again, as I said, you look at the calculations which are done yearly. You also look at half yearly and so on. So it will be up to you now to make a decision based on the different, years, the different calculations rather. If you look at the first calculation, if it is just done yearly, meaning that once a year, the number of years there is one. So if you do it once a year, the amount of your investment will be 33,671 rands and 7 cents. So that is if you take your investment and then you just calculate it yearly, every year. So if you do it half yearly, meaning that there will be a process half yearly. Remember, a year consists of 2 halves. And of course, this simply means it's going to be 3 times because it's 1.5 years. So in 18 months, then you will have to compound your interest 3 times. So you can tell that if you compound it 3 times, then it will actually give you a different amount, because 1.5 times 2, of course, that gives you 3. So it means your interest will be calculated 3 times, which is opposed to the next one there, where you multiply 1.4 by 1.5 by 4. Remember, if you do it quarterly, then it means because a year consists of 4 quarters, and half a year will consist of 2 quarters. So it will be 6 all in all. There will be 6 quarters there in 18 months. You can tell that if you compound it 6 times, it will increase your investment. But then the most interesting one is the daily one. If you compound it daily. So once again, you're going to multiply 1.5 by 365 days. So basically, it will be done 547 times, because in 1 year has got 365 days. Then if you divide that by 2, it will give you half a year. Remember, this is 18 months. So in 18 months, if you compound your interest on a daily basis, you shall have compounded it for about 547 times if you do it on a daily basis. And you can tell that if the interest is compounded daily, the chances of your investment increasing are very high. So if you get interest every day and the next day you add another interest which is compounded, then your investment is likely to increase rapidly, rather than if you do it just once a year. You can already see the difference between the initial accumulated amount, which is 33,671 rands and 7 cents. So there's a huge difference there between the first investment, which is accumulated, and the last accumulation there. Because the last accumulation, as you can tell, that is 33,000 rands, 828 rands and 17 cents. So 33,828 rands and 17 cents. And of course, if you were to subtract this particular accumulated amount, which was done in the beginning of the activity there, you can see that there's a difference of 157 rands and 10 cents. So this actually tells you that the daily accumulation is far much better than the yearly accumulation. So to add interest only once a year, that is if it's the same interest. If you add the same interest, the compound interest in this case, it will be better if you compound it daily rather than annually. So if you do it daily, we can tell that, you know, and this is, by the way, this is just 1.5 years. That is just 18 months. So you can imagine that if the investment was to last for a period of 10 years, for instance. So after 10 years, the investment will be far much better if the compound interest was calculated on a daily basis as opposed to on an annual basis. So annually is quite different from the daily. I hope that once again, you can be able to tell the actual difference. Now, we look at the next one here, where Joseph must sell his plot on the West Coast, and he needs to get 300,000 rands on the sale of the land. Now, if an estate agent charges him 7% commission on the selling price, what must the buyer pay for the plot? Now, Joseph has to sell his plot on the West Coast, and that what he needs, he only needs 300,000 rands on the sale of the land. Now, if an estate agent is going to charge him 7% commission on the selling price, what must the buyer pay for the plot? So you can tell that usually when you sell a car or when you sell a house or a plot in this case, you may need your own, you may sell it for 300,000 rands in the case of Joseph, just as he did. But of course, the estate agents as well will charge you a commission, you know, because they need to make money as well, you know, when they process the sale of your property. So in this case, Joseph as a estate agent will charge him 7% commission on the selling price. So what must the buyer pay for the plot? So now we need to check how much will the buyer or the prospective buyer pay in addition to you know, what Joseph needs. Now, once again, very important, we have a responsibility to identify the data, what is given and what is not given there. And so that we are able to check what is it that we need. Now, so at this point, what we know that the estate agent is going to charge Joseph 7%. And of course, we also know that Joseph needs an amount of 300,000 rands. So we are going to say, let the selling price be K. So we have taken K in this case. We usually use X, which is the most commonly used letter to find any variable. But in this case, I've just chosen to use K for a difference. So let the selling price be K in this case. So now that we know that the selling price is an unknown because we don't know what the selling price is, that is what we need to find out. So that is what the question wants. So what must the buyer pay for the plot? So the buyer has to pay a particular amount. In this amount, 300,000 rands will go to the seller, in this case, the seller being Joseph. But we know that 7% commission is also required by the estate agent. And the estate agent in this case is a person who sells the property on behalf of the seller. You know, it's a sort of a middleman, if you can put it that way. Someone who's going to sell the property on behalf of the original seller, in this case, the original seller being Joseph. Now, we have identified what is given, and we know that the amount, the accumulated amount, or rather the amount that will be paid by the buyer, we have to take the original amount into cognizance here, 300,000 rands, that is the amount required by Joseph, plus the 7% of the commission, which is required by the estate agent. So this will be 7% off. It's 7% of the amount that you know, is going to be used to sell the property. So that amount is K in this case, as we have said, the selling price. And of course, once you take both of them, once you take the original amount, which is required by Joseph, and then you add 7% of the selling price, then you actually get the selling price itself. All right. So in this case, you tell that we are now going to divide 7 by 100. That's because any percentage, if you have 7%, you know, this is 7 out of 100, which gives us 0.07. Now, at this point, you can make K the subject of the formula, or you can rather collect what we call the lag terms. So the lag terms in this case will be 0.07 K as well as K. So K minus 0.07 K, and you are left with 300,000 rands in the left-hand side. So this is 1K. We know we don't always write the coefficient of K, which is 1, but we know it's there all the time. So 1K, or K as we call it, if you subtract 0.07 K, you'll be left with 0.93 K. And now we need to make K the subject of the formula by dividing both sides by 0.93. Remember, as always, that whatever you do in the left-hand side of the equation should also be done in the right-hand side. In the same note, whatever you do in the right-hand side of the equation must be done also in the left-hand side. And the main reason for this is that you need to keep your equation balanced at all times. So we are going to divide 0.93K by 0.93, and you do the same, you divide the same, or 300,000 rands, you divide that by 0.93. And this simply means that your selling price, which we classified as K in the beginning, will be 322,580 rands and 65 cents. So basically, once the estate agent has sold the house for this amount, then the estate agent will be able to transfer 300,000 rands into Joseph's bank account, and the remaining amount will be 22,580 rands and 65 cents. So this means that the commission that will be made by the estate agent in this case will be 22,580 rands and 65 cents. And this will be the commission of the estate agent. And if you want to test, I always say it is very important to test whether the amount is correct or not. In this case, we have already rounded off our figure there, the final figure. Remember that when you divide 300,000 by 0.93, you actually get a very long number there, when you divide the two. So basically, when you divide 300,000 rands by 0.93, the amount that you get there will be 322, so it's 322,580 rands and 64 cents. It's 64516129. And the amount that we have here, it's an amount that has been rounded off. So as you round off there, you will be able to tell that this will be the amount. Now, if you take this commission, which is not rounded off, if you take the estate agent's commission of 22,580 rands and 65 cents before rounding off and divide this by 300,000 and thereafter multiply everything by 100, you will be able to actually see that the 7% that we spoke about comes into play. In my case here, it actually gives me 7.5%. But remember that when we began this, before we calculated, we said the estate agent has charged him 7% commission on the selling price. So basically, this is the same. 7% will be the interest that has been charged by the estate agent. So you need to be able to work backward as well in order to test or to check whether your amount is still the same, whether they correspond. So corresponding values, very important. So basically, this is what we need when we look at the amount. The amount that Joseph will get, which is of course the same one. And of course, we are going to now proceed just to ensure that we move towards the relevant one. Right, let's look at the next one here. We are going to look at an investment here, which is the investment of 500 rands in a savings plan. So the investment of 500 rands for a period of 4 years. And once again, we need to know that if you make such an investment of 500 rands for a period of 4 years, you receive about 10%, which is interest. So we have to now calculate what will be this interest that you'll get if we look at the simple interest rate as well as the compound interest. Now, there's quite a huge difference between the compound interest as well as the simple interest. Let's look at the two. I've already shown you even previously that when you make an investment and receive a simple interest on the investment, if the interest is the same, the value of the interest, if it's the same as the compound interest on the same investment, the one who chooses the compound interest is likely to make more money. In other words, the investment will be far much better if you select the compound growth rather than the simple interest growth. Now, in this case, if we look at this investment of 500 rands which is calculated at the start of the investment, you simply look at the simple interest. And of course, the simple interest simply means it's interest charged on the original amount there. So the original amount is 500 rands. We know that 10% of 500 rands will definitely lead to 50 rands. So this means that if you are going to save, or if you are going to invest for a period of 4 years, by the end of the first year, you will have 550 rands in your bank account, which is simple interest. By the way, they work the same. Always the first interest for both compound and simple interest works the same. At the end of the first year, you will have 550 rands. And of course, in the second year again, you do only the interest there, which will be the same. And you can see that at the end of the second year, you simply add another 50 rands, to the original amount that you had at the end of first year. So from 550 there, you will add another 50 rands. So you'll get 600 rands at the end of the second year. At the end of the third year, of course, you will have now 650 rands. So your annual growth will just be 50 rands, which is simple interest. So at the end of the fourth year, you can see that you will have 700 rands, which is added on the initial amount there. Now, basically, this is what we want to talk about. And of course, I'm just going to zoom directly into the next phase, which in this case is calculated to be another compound interest. So compound interest will be different from the first interest there, which is simple interest, because in this one, the accrued amount will just be 700 rands. So you can see that the principal amount was 500 rands, so the growth there was just 200 rands at the end of the 4-year period. Now, this is basically different from the one that we have just looked at now. Very different, because in this one, you can tell that at the end of the first year, the investment will be 550. Just like the original one, you can see that even here, the investment at the end of the first year, I'm saying that the simple growth plan at the end of the first year is the same as the compound growth plan, because the amount is the same. You can see that in the first simple growth plan, the end of the year, the amount had increased by 50 rands. So you had 550 rands. The same goes for the compound interest. At the end of the first year, the investment is 550 rands. So they are equal. The only difference, however, will be when it comes to the second year now. In year 2, you will be calculating interest on interest when we talk about the compound interest. So in this case, you'll start to see the difference between how the compound interest operates as opposed to the simple interest. Now, in year 2, as I've already indicated, you will have the interest of 550 rands. And of course, you multiply that by the interest. So at the end of the second year, you are no longer adding 50 rands to your investment. You now add 55 rands. And why do you add 55 rands? This is simply because we are now calculating interest on the original amount, which has interest already. That's why we call it interest on interest. So you are actually calculating the 10% interest on the total amount, which is 550, as opposed to the, doing it once in the simple interest. So you can tell that by the end of the second year, you will have 605 rands as opposed to the 600 rands that you had with the simple interest rate. And once again, by the end of the third year, again, you do interest on interest. So in other words, you calculate 10% of 605 rands, which is the total amount. And this will lead you to a new interest value of 60 rands and 50 cents. And if you add that to 605 rands, you will get 665 rands and 50 cents. And you can tell by the fourth year, once again, you'll be able to add your interest. And this means that it will increase once again. It will increase, and by this time, it will be 66 rands and 55 cents. So what is important here is to make sure that we calculate it in such a way that we will be able to look at the remaining amount and the final value there of the investment after a period of 4 years will go to 732 rands and 5 cents. So you can see that when we look at the difference between the simple interest amount or the simple interest rate as well as the compound interest, the compound interest will definitely yield better results as opposed to the different 1 year, which is the simple interest. So basically, the amount that will be accrued from the original investment of 500 rands under compound interest will be much bigger than under the simple interest. So basically, when we look at our growth path, there are 2 types of growth that we look at. The first one is the simple growth, followed by the compound growth. This simply means that A, as I've said, stands for the accrued amount, and P stands for the principal amount, whereas I stands for the interest rate. And N in this case is the number of years or the number of times interest is calculated. Remember that we already said at some point 18 months was the number of times. So if you do it on a monthly basis, then it will be 18 times. So that is the number of times. But then again, we looked at the daily. When interest is calculated daily, we know that a year consists of 665 days under normal circumstances. And so if you are doing it for 2 years, for instance, and you have to calculate it on a daily basis, then this simply means you will have to multiply your 365 by 2. So this will give you the number of times that the investment will be done, or the number of times wherein interest will be charged. So in this case, if it is 2 years and done daily, it will come to 730 days. So that will be 365 multiplied by 2. Now, we sometimes find errors which we are not going to look at all in all, but sometimes the accrued amount is the amount that will be received at the end of the investment. So please make note that this is not the same as the interest that will be earned. The accrued amount is actually the principal amount plus interest. That will be the accrued amount. Once again, when you look at the interest rate, as I always say, when you are given 6%, you need to know that 6% simply means 6 out of 100. So you must divide your interest, as always, by 100 in all calculations. In other words, if you want to modify your formula for simple interest, you may do so that you don't go wrong in the exam. You need to know that your interest has to be divided by 100. So that is why we have shown you here that you can simply divide interest by 100. And this applies to both equations, the first one being the simple interest equation, followed by the compound interest equation. And of course, this is done so that learners are able to remember the importance of dividing by 100. The reason why we are doing this, there's always a misconception. Sometimes learners just put 6 for 6% when it comes to replacing the I, the interest variable there. Sometimes if we say interest is 8%, then there are learners who will just put 8 and not necessarily divide it by 100 just to show that this is interest. So interest is always divided by 100. That is what I'm trying to say. And of course, having said this, we are now going to carry on with our role of looking at the investments as well as the different options that are available. Let's say that you are now going to look at 5,000 rands, which is needed. And then of course, if you borrow this amount of 5,000 rands at a simple interest rate of 15% for a period of 2 years as an option, together with borrowing the same amount at a compound interest rate of 5% also for 2 years. If we want to check here which option will be much better compared to the first. The first one, you borrow money now, about 5,000 rands. The interest rate that is charged is simple interest of 15%, which is calculated per annum for a period of 2 years. But then again, you can borrow money, 5,000 rands in this case, where the money will be charged 5% compound interest, also for a period of 2 years. Let's look at the two investments or the two amounts so that we check what the accrued value will be of 5,000 rands at a simple interest rate and thereafter at compound interest rate. So you can tell that the first one here, when you look at the simple interest rate, your interest now becomes the coefficient of the number of years, which is 2 years. And as always, we say that the 15% must be divided. You divide that by 100 to say this is 15%. So 15% simply means 15 over 100. And this is 0.15. And if you multiply that by 2, it will give you 0.3. So if you add 1 to 0.3, you get 1.3. And if you multiply that by the value of your loan, this becomes 6,500. So 6,500 rands, this simply means you are now, it means that you are now going to pay an additional amount. If you divide that 6,500 by 24 months, which is 2 years, then it means on a monthly basis, you will have to pay 270 rands and 83 cents. And this, of course, happens under the actual, simple interest. Now, what are we going to do to look at the compound interest? We obviously going to use the actual formula to calculate the simple interest, the compound interest rather. And you can tell that this time the n, which is the number of times where the interest can be calculated, will be 24 months because it's also 2 years. But look at the difference now. The difference in this case is that you have 5%, which is far less when you compare it to the 15%. But this will yield a greater amount, accumulated amount of 16,125 rands and 50 cents. And this is for the main reason that I've spoken about many times now, that when you divide this amount by 24, you will have to settle for the monthly repayment of 671 rands and 90 cents. And if you look at this amount and compare it with 270 rands and 83 cents, despite the fact that the simple interest is 15% and the compound interest is 5%, we still see the compound interest yielding a better or a bigger accumulated amount. And this is because even though the compound interest is less compared to simple interest, the fact that it is charged on interest, interest on interest, that is why it will gain momentum. And at the end of the day, whether it is an investment or whether it's a loan, the amount calculated under compound interest will be far much bigger than the amount which is calculated under simple interest. It would appear that 15% was far much better compared to 5%, but in this case, it's not the case because the compound interest is calculated on interest. So interest will be calculated on interest. Now, from these calculations, we can tell that the second option has got a total repayment of 9,625 francs and 90 cents more. And even the monthly amount or the monthly repayment is 401 rands and 7 cents more than the first option. So how do you get this? You simply take 671 rands and 90 cents and subtract 270 rands and 83 cents. And that is why the answer that you'll get will be 401 rand and 7 cents. That will be the amount that we will get. That will be the amount that we will receive. And basically that was to just demonstrate the difference between the two. So it's very important to always look at the difference between the simple interest as well as the compound interest. In many ways, even though the simple interest may appear to be bigger than the compound interest, we first have to check by way of calculation before we can make a conclusion. And of course, this applies across the board in real life situation, whether you buy an item at the store, always check that compound interest is always used when it comes to higher purchase. If you buy a microwave, for instance, which is worth about 1,000 rand, if you buy it for cash, then it will be less than when you buy it on higher purchase, because on higher purchase, interest will be calculated on interest. Okay, that is the first one there. And I'm not going to waste more time, but just to look at the formula that we spoke about, we are going to use it a lot. This time, I want us to look at the compound interest where there's an investment. Let's look at the investment of 10,000 rands, which is now invested at 12% per annum, which is compounded quarterly. We are informed that the growth of the investment can be tabulated. And of course, we know that the interest rate is 12% per annum. This is the rate at which interest will be calculated per quarter. Once more, it is important to understand what the question needs here. If 10,000 rands is invested at 12% per annum, compounded quarterly, now compound interest once again comes into play. But now we are told that it is compounded quarterly. And what does quarterly mean? How many quarters do we have in a year? So when we talk about a quarter of a year, that is just 3 months. So basically there will be 4 of those. There will be 4 quarters in a year. And this simply means the 12% interest will be charged 4 times a year. When we say the 12% per annum will be compounded quarterly, so it means it will be charged 4 times in a year. Now, in the beginning of the year, we normally say, or in the beginning of the investment rather, it's just like the speed of a car. Before you can even start your car, the car is already at 0, meaning that it is stationary. So you cannot look at the speed until it starts moving. You know, even if you look at the speed, but the car will be at 0 miles per or kilometers per hour, right? After the first quarter there, you can see 1, then we can start looking at the growth of the investment. But initially, it's just like when you deposit the money. The day you make a deposit, the interest is 0. So there's no interest that will be added to your investment when you deposit it on the first day. But after the quarter, or after the end of the first quarter, we definitely expect some developments there. 12% per annum, which is now calculated per quarter. It means if you divide 12 by 4, you get 3. So it means it will be 3% every quarter. The first 3% will be charged in the first quarter there, and the other 3% in the second quarter, and so on, until they make a total of 12%. Now, in the first quarter, without doubt, we use the compound interest formula. So now the compound interest formula will give us the actual amount that we need. And in this case, the amount will be, we now multiply our principal amount, and of course, we multiply that with P. A is equal to P into 1 plus I over 100, and then all to the power n. And this means that 1 plus 3 over 100 there, and the number of years there, since it's the first quarter there, you just put 1. So the number of times will be 1 because it's the first quarter there. It's just once. Or the number of years, in fact, it is done per year, yes. So the number of years will be 1. And of course, it will yield 10,300 rands. That will be the first quarter. So at the end of the first quarter, the amount will be 10,300 rands. Now, the second quarter, of course, you take the same amount now. Now, notice the difference. Although our initial investment was 10,000 rands, at the end of the first quarter, we are sitting with an investment of 10,300 rands. So it will be 10,300 rands. That will be the amount. So the second one there, the 10,300 rands now becomes your original amount, which is the principal amount. So now P, or the value of P rather, is now changed. So now that 10,300 rands becomes your principal amount, you now have to use the same formula again, compound interest. Again, the number of years is 1. The interest is 3%. And once you have finalized your calculation, you'll see that at the end of the second period, or the second quarter rather, you will have an amount of 10,609 rands in the bank. And this, if you look at the third quarter now, 10,609 rands becomes your principal amount. So every time it has to become a principal amount because we are charging interest on interest. And of course, at the end of the third quarter there, you can tell that the amount will grow to 10,927 rands and 27 cents. And once more, this becomes your principal amount when we enter the last quarter of the year, meaning the fourth quarter now. So if we are at the fourth quarter, once again, the interest is 3%, the year is just 1, and you again use the compound interest formula. A is equal to P into 1 plus I all to the power n. We have simply divided by 100 here just to show you that the 3% simply means 3 out of 100. Now, at this point, the final amount is 11,255 rands and 9 cents. Remember that this amount, the original amount was 10,000 rands. This is where we took the original amount. It was 10,000 rands, and it has now become 11,255 rands and 9 cents. And of course, you can tell without any doubt that your investment has grown by an amount of 1,255 rands and 9 cents. So the percentage increase, if you want to check what was the percentage increase, you simply take the amount by which the 10,000 increased, and that is 1,255 rands and 9 cents, and you divide it by 10,000. Thereafter, you multiply the product, yes, you multiply everything by 100 in order to get 12,5509%. Therefore, it can be clear from this example that this interest rate of 12% is also known as the nominal interest rate. So if anybody wants to calculate the nominal interest rate, you will know that it will be, the amount by which your investment has grown, and then you divide that by the investment itself, which was made at the beginning of the investment, and then you multiply everything by 100, and you will be able to get the nominal interest rate. So the actual interest rate in the investment, which grew by a year, is 12.55%. That is what we have now. And of course, This 12.55% is the effective interest rate. So basically that is what we have. So you should be able to analyze the difference between the effective interest rate as well as the nominal interest rate. There's quite a difference between the two, as we have just shown you. The nominal one appears to be the one that you had even in the beginning, whereas the effective was just calculated now. And of course, the formula, this is the formula that we can use to calculate the effective interest rate relative to the nominal interest rate. So at times, you may be given the nominal interest rate, and you may be required to find the effective interest rate. As long as you are given the number of times that the interest is calculated per annum, you should be able to calculate the missing link there. So once more, it's very important at all times to look at the given data. So, but also to remember that this formula just shows you the comparison between the nominal and the effective interest rate. So the investment period in principle is not relevant to this calculation. Right. I'm just going to give you an example now. Suppose you are given the effective annual interest rate, which is now 11.8%. And let me once again indicate that when you are given 11.8%, please do not round it off and make it 12%. There is a tendency by some of the learners to round off. You don't round off the given percentage, but you leave it as it is. Now, in this case, you are given the nominal interest rate. And what we need to calculate, we have to calculate the effective, we have to calculate the interest. So we are given the nominal one, and then we need to find the effective interest rate there. So the solution, we know that the interest is 11.8%, and we are just going to substitute it here. And then we multiply 100 by 4, because this is compounded quarterly. 4 times a year, that is what the compounded interest means. It's compounded quarterly. So it means that it is charged or calculated 4 times a year. So because there are 4 quarters in a year, like I said already, in this case, you utilize the formula. And in this case, M will be the number of times. So it will be 4 times in a year. And then the I will be the nominal interest rate divided by, remember interest you need to divide by 100, but also you divide also by the number of times, which is times 4 there, for 4 quarters. And of course, you make the effective rate of interest annually. You make it the subject of the formula. And of course, you can see that at the end of the day, you'll be left with 0.12332. And then you have to multiply that by 100, and this will give you 12%. So at this point, you once again will be able to tell the huge difference that exists between the effective rate of interest. Not necessarily huge difference, but the difference that exists between the 2 types of interest. So the first one is the nominal interest rate, which was given at 11.8%. And using this same interest, we were able to calculate the actual effective annual interest rate. And that is basically what we have just done now. And then the next one, of course, you can tell that if you are given the effective interest rate, you should be able to find the nominal interest rate. Let's assume that you are given the effective interest rate of 12.4%. And then you need to find the nominal interest rate, which is compounded on a monthly basis. You can be able to use the equation once again and make I to the power m the subject of the formula. And of course, at this point, you can see that the most logical thing to do, you simply add 1 and 0.124 in the left-hand side. Where do we get 0.124 from? That is the 12.4%, the effective interest rate that is given. So you simply divide that by 100. Remember that interest, as always, must be divided by 100. So once you divide this 12.4% by 100, you will get 0.124. And then if you add this same to 1, then you'll get 1.124. Then you introduce the 12th root, both sides. Whatever you do in the right-hand side must also be done in the left-hand side. So basically, you'll have the 12th root of 1.124 minus 1. And this is equal to I to the power of m divided by 1,200. And then if you multiply both sides by 1,200, you can tell that I to the power m will be equal to 11.75%. And without doubt, you can see that the nominal interest rate is less than the effective interest rate. And even if you were to go back to the previous example, once again, you will see that the nominal interest rate here is less than the effective annual interest rate. I think this is the comparison that we need to make at all times, as and when we calculate the unknown, be it the nominal or the effective interest rate. Now that we can see the difference are there between the nominal interest rates as well as the effective interest rates. It is necessary for us to check also the previous equations so that learners do not, they don't have to face any difficulty. We look at the compound interest. Basically, this is the one that we use when we look at the nominal as well as the effective rate of interest. So this is where we are now. I to the power m simply stands for the nominal interest rate, and m is just the number of times where interest is charged or calculated per annum. So if it is quarterly, remember, per annum there are 4 quarters in a year, and then it means interest, that's the number of times where interest will be charged. And of course, T simply stands for the time period, for the investment. It can be invested for, say, 10 years or 5 years. That is the time period. And of course, this is what we have done now. Now, the next example looks at the investment which is done for a number of years as well. You can see that the investment of 12,000 rands was made into the savings account where the interest rate of 10% per annum compounded quarterly for 3 years. And of course, you can see that another 5,000 rands was deposited into the savings scheme where the interest rate changed to 10.8% per annum. So of the fourth year, this is now compounded biannually. So we need to be able to interpret these different concepts of biannually, quarterly, and so on. So quarterly simply means it's 4 times a year. So if it's 3 years, then it means you multiply that by 3. Biannually simply means 2 times a year. Now, if the money is kept in the account at an interest rate of 12% per annum, we need to develop a timeline just to demonstrate how the investment, has grown, and also to determine the value of that particular investment after a period of 6 years. So you can see in the beginning, as always, I give an example of a car, that if a car is not moving, then you'll have 0 kilometers per hour. The same goes for the investment. If you deposit your investment today, if you make a deposit today, it will not grow because it was just done today. So it will still be the same. But after the first term, then you can start seeing the movement or the difference in as far as your investment is concerned. And then basically, we look at the investment which has grown, and we look at the different percentages there. The first 3 terms there, remember we said initially, when we started, we said it is compounded quarterly for 3 years. And of course, you can tell there that for 3 years, 10% there, that is what was given. The interest was 10% per annum compounded quarterly. So for 3 years, we have got 10%. And then we also have a further 5,000 rand, which was deposited. The interest rate changed to 10.8% per annum. So this is where the 10.8 comes from. So the T3 there, from T3 to 4. So we already know that this is the 4th year. So in the 4th year, we now have an additional interest of 10.8%. And of course, this is compounded biannually. Now the money was kept for a further 2 years at an interest rate of 12%. So a further 2 years simply means from 4 years there, you'll have 5 and then 6. So a further 2 years at 12% per annum, which is compounded, which has got compound interest. So we have just shown you now the timeline in relation to these investments that were made. You can see that the first investment that was made there was 12% in the second year there. And then in the second year, we had an additional 5,000 rands, which was deposited, as the statement has said. A further 5,000 rands was deposited. So the initial investment was 12,000, but in the process, after 2 years, 5,000 rands was also deposited. Now, at this point, we need to check what the investment or the value of the investment was at the end of the second year. Remember, at the end of the second year, that is where we looked at the 10% there. And of course, we are looking at the 12,000 rands. Now, 12,000 rands has now grown to 14,620 rands and 83 cents. Remember, do not round off before the final answer. Very important, never round off before the final answer. So at the end of the second year, the investment will be 14,620 rands and 83 cents. But we write 83477 because we cannot round off before the final answer. Remember, that's the end of 2 years, so we have got 2 times 4. Why do we multiply 2 by 4 in the exponent here? That is the term, 2 years times 4 quarters. So it will be about 8 quarters in 2 years. All right. Now we are told that at the end of the second year, a further 5,000 rands is invested into the account. So in addition to the accumulated amount of 14,620 rands and 83 cents, we know that an additional 5,000 rands was deposited into the account, which brought the account to an amount of 19,620 rands and 83 cents. Once again, you don't have to, you don't have to look at the comma there. 19,620 rands, comma 83477. So no rounding off until the final answer. So as we enter the next step, you can see that from T2 to T3 in the number line, we begin now with a bigger amount of 19,000 rands, 620 rands and comma 83477. And then we invest this for, it's now once a year. Remember, it's just per year for 1 year there, and then the compound interest is calculated quarterly, as we know. So it will be 1 times 4 because of 4 quarters there. And by the end of this third year, we will be sitting with 21,657 rands and 73 cents. And that is what we will be sitting with. So from T3 to T4, once more, you can tell that the biannual kicks in now. Now we are doing it per year, but biannually. So it will be 1 year from T3 to T4, it's just a year. But since the investment is now calculated biannually, compound interest, you take the same one. Remember, the interest has now changed. It's now at this point 10.8%. And remember, you must divide it by 100. And because it is biannually, then you divide also by 2. And of course, by the end of the 4th year, your amount will now be 24,059 rands, 91927. Again, you don't round off until the final answer. Very important, do not round off until the final answer. And then from we know that from T3 to T4, we now have 24,059 rands, 91927. And we are now going to look at the last 2 years now, where interest will be charged only once. Remember that the last 2 years, once again, the last 2 years, it will be 12% interest. So you take the 24,059 rands as it is, 91927 without rounding off, and then you put it as your principal amount now. Once you do that, at 12%, remember to divide by 100, and then you multiply by 1, because it's just going to be once a year. So it's 2 years at compounded just once a year. And of course, the final amount will be 30,180 rands and 76 cents. You can see at this point that for the first time, we have now decided to round off. Why did we round off at this point? Because this is the final answer. So in the final answer, the rounding off kicks in. So always remember that rounding off is very important. We need to round off in the final answer. I hope that we will be able to look at that and be able to analyze it. We will be able to analyze that. And as we wrap up our lesson now, so basically at the end of the year, the 6th year, the amount of money will be 30,180 rands and 76 cents. So remember, now I want to take you through the timeline just so that you know how the timeline works. When we use the timelines, we always start with a T0. As I've said to you, the car also starts with 0 kilometers per hour. Well, T0 in this case is the start of the first year. And then T1 becomes the end of the first year. I hope that it makes sense. So we always write T0 there when you begin the year, because the year has not yet ended. You are still at the beginning. So you start with 0. But T1 simply means the year 1 has ended. And then, of course, you can be able to find the difference in the investment that you made. So T1, once again, is also the start of the second year. So T1 may be the end of the year, but it's also the beginning of the second year. So this means T1 is the beginning of T2. So the second year begins with at the end of T1. And then, of course, the same goes for T2, which marks the beginning of T3. So now you can check here that we did not use any equation for all calculations. And of course, the intermediate answers, you don't round off until the final answer. So only the final answer is rounded off, as I've said. But then again, you need to check and see for yourself that the accrued amount at the end of a particular time period becomes the principal amount for the next period. We have shown you this many times. So at the end of T1, meaning that at the end of the first year, you'll have the accrued amount. That accrued amount becomes the principal amount for the second year. At the end of the second year, you'll have that has been accrued, and that amount becomes the principal amount for the third year, and so on. So basically, that is what you do. And of course, this requires that we understand the question together with the terminology. For now, I'm just going to look at the last example here. Once again, Johnny buys a car for 300,000 rands. And now we look at the different depreciation value. Remember when I started this lesson, I started with depreciation, straight line depreciation, as well as reducing balance depreciation. I used an example of 6%. And this time we are looking at a different one now. We are looking at the car which was bought for 1,000 rands. And we are told that the car depreciates at 12.5% per annum on a straight line depreciation. So what will be the value of the car after 5 years? So remember, there are two ways in which we can do this. One, I've already shown you. You can use the formula. You can utilize the formula. Remember that the formula that I said that you need to look at the 12%. In this case, 12.5%, and you divide that by 100. It will give you 0.125. And the number of years will be given by 5. So you multiply that by 5. If you multiply this by 5, you get 0.6225. Remember, since this depreciation, it means this value has to be subtracted from 1. If you subtract this value from 1, you are going to have 0.375. And then if you take the 0.375 and then you multiply it by the original value of your car, you will see that the amount that you'll get straight away will be 112,500. This is the amount which you will get when you use the formula. Now, there is a different way of doing this calculation without relying on the formula. Sometimes people may forget, if you forget, because there are learners who tend to memorize the formula, for instance. So if you forget one aspect of the formula, it can actually destabilize the whole process of your calculations. Now, here's a different way. These calculations can be done as follows. We know that 12% or 12.5 rather, 12.5% simply means 12.5 over 100. And then you multiply that by 300,000, you get 37,500. So this means that the car will lose its value, the value of 37,500 every single year. And in this case, you can be able to work out a table for yourself where you look at the age of the car in years. Remember that when you buy the car, when you take it out on the first day, you are still at 0 now. The value of the car, because it's a brand new car, the value is still the same. It's 300,000 rands. It's only at the end of the first year, on the same date that you bought the car, that we start evaluating the value of the car. And since in this case, the value that is lost will be 12.5%, it simply means you are going to subtract 37,500 from 300,000 rands. And this will give you the value of the car at the end of the first year. And then you do the same with the next one. At the end of the second year, you also see that the value of the car will be reduced by the same amount. You do the same for the third year, fourth, and fifth. And as I've predicted, or as I've said initially, the final value of your car will be 112,500 rands. So to find this value, you can either use a formula or you can calculate the 12% of your, or 12.5% of the total amount. That will give you the amount of money that will be lost every year from the car. So this is very simple. You can be able to work it out on any vehicle as long as you have what is known as the depreciation percentage. So if you are told that the car is at 12.5%, then you can be able to work out the value of the car after a period of 10 years. And by the way, you can do it, with any number of years. It can be done with any number of years. And then that brings us to the end of our lesson. And of course, I'm not going to look at other problems. What I want to say is that this lesson was brought to you by the Africa Teen Geeks, which presents the STEM Digital School in partnership with the Sasol Foundation. Until we meet in the next lesson, thank you very much indeed.